Okay, so as I showed you earlier, you've got the burner down here, and then over on the other side here, this is where all the controls are. In order to open this, this has to be in the off position. These should always stay the same with the run on auto and the dehumidifier run on auto. That S1 and S2 corresponds with what's in here. This has got this little door holder to hold the door open. So this is where all your wiring goes through. These are your fuses. These are the relays that control various aspects of its operation. These are the motor starters, or the motor, well yeah, I guess the starters for the motors. They are what energize each of the motors. These are timers. That's a transformer. This is your on-off. If you do have to turn the unit on in order to troubleshoot, you do it with a wrench with the door open. Use a crescent wrench. It's your ground wire. Those are your 600 volt power lines. So that is all 600 volt, and all the control voltage is 120. In terms of the what does what in here, so over here behind this door you'll find a wiring diagram. The wiring diagram shows you what does what. I'm just going to close those because otherwise they'll get broken off by the door. Okay, so here is your wiring diagram. This will show you what's connected to what. It takes a little bit of time to really get to understand it. Essentially what you have to do is you have to trace things back, looking at what's what. So I don't know what's a good example here. I don't know, problem that was previously being troubleshooted. So for example, we had an intermittent issue with the gas valve. So by tracing where the power was getting dropped out using the wiring diagram, I had the power logger hooked up to the wiring that ran various things where the voltage was getting dropped, and in order to determine where the power was getting dropped, the power logger logged all the details, showed where it dropped out, and it turned out being inside here. It was the little safety switch for the gas valve. So we replaced that, and that solved that problem. We've had other intermittent issues with thermostats and things like that. Right here, this, and this, these are all airflow switches. Those airflow switches prove that there's airflow before firing the burner, so that way the burner doesn't get fired if there is lack of airflow. Also, this burner control, this piece here comes off, and Alex from Honeywell has got a screen that can get attached to this, and then that gives you troubleshooting and diagnostic information on any issues that come up with the boiler. It'll also show you runtime and all those types of details. So if you ever need to, Alex from Honeywell can help troubleshoot that burner control. This burner was replaced recently. Some of these airflow switches have been replaced. Anywhere that you see numbers written on them, so 17, 8, 2, 8, 12, all these numbers correspond with where it's running in here. So if you're trying to check for power at different spots using your voltmeter, you can easily match up what's written on here with what's on here, and then that also matches up with this wiring diagram here. And so your wiring diagram will show anything that's not labeled. So these ones have been labeled for ease of troubleshooting. Other ones that are not labeled, you'll have to reference the wiring diagram. Something else that I've done to help aid that is in here. This has got a whole bunch of information in it. Everything from the manual to things like additional copies of the wiring diagram. And there's also a bunch of print-offs. And so these print-offs can be quite helpful. So it shows in detail what things normally have what power when it's running. So here this shows all of this normally has power when it's running, except for these terminals. They don't have power during normal operation. It just is one way to help troubleshooting. And then that's the same thing here. So this page here, it shows what power you should normally have during normal operation. So if you're getting something different than this, then that'll help you track down what the problem is. And all of these just have notes on them from various times that I've been doing troubleshooting on the units. This is a close-up of the relays, so you can see whether it's energized or not energized based on which side of the contacts are on. And if you're troubleshooting something in here that's electrical, CAPI can definitely assist with that, especially using these sheets. But if it's anything more to do with the actual running of the unit, then you probably want to get Alex from Honeywell to come and help you, because he knows this unit better than anyone else. This here is the heat wheel, or sorry, I should call it the desiccant wheel. So this wheel spins by this belt that's driven by this motor, and this is a switch to verify that the wheel is spinning. That's a safety mechanism, because if the wheel's not spinning, then you can have these burn up. Apparently units have caught on fire. So this switch, see it's labeled over here, that's going to correspond to your wiring diagram. And if for some reason this has come loose or something, this isn't engaging, that'll shut the unit down. Over here, this is reactivation. So this is basically checking the temperature on, like you can see where it comes here and it goes through there. It's recording the temperature on the other side of that. Same as this here is measuring the pressure on the other side of that, and you can trace that back to the other side there. And all this stuff is nicely labeled for the most part to help it make it easier to trace issues. Same here, everything's labeled. So TC, TS, you can trace all those back to the wiring diagram. And then there's another one that's around this side. And so over here, this motor here does your burner airflow. These are your filters for your air. This here, this is what controls the temperature setting for the air. So the point of that is to, if the outside air is too cold, it would be coming in through there, it'll shut the unit on and off based on the outside air temperature, because actually if it's cold enough outside, then you theoretically wouldn't need the unit to run. In our case, this is actually closed off, and I think that's going to get changed with the BMS system being added. So from this angle, you can see that's where the controller is. Over here, this is the other side of the heat wheel that you're seeing, or the desiccant wheel. And that desiccant wheel was just replaced summer of 2016, and it was about $15,000, so we want to make sure that we look after it properly. So essentially what you've got happening is burner is pulling in air through this filter from outside. It's being pulled through here by that motor there. It's going through 1/4 of the wheel. So if that wheel was out of here, you could see where the air flows through there. 1/4 of the wheel gets the hot air from the burner drawn through it. That dries the wheel out, and then the wheel rotates really slowly. And as it turns around the other side, it's picking up moisture from the air that's flowing through the other side. So it's sending dry air back to the arenas there. It's bringing the damper air through this side, and then the hot air that's going through to dry the wheel out through here is being expelled through this exhaust vent here. And the motor that runs the air through the unit and through the arenas is over here. And so both of the motors in this were replaced recently, within the last 2 years. So this motor is brand new, and so is the one over there. This is what is moving the air through here. You never want to open this door with that running, because there's massive positive pressure there. And this wheel takes a long time to stop spinning after it's shut off. So you'll see here that it has warning labels to make sure that you disconnect before servicing and not to open due to the positive pressure. Now, as I said, both motors were replaced recently, and all of these parts here, just about, we don't have a spare one of these, but we have a lot of spare parts for this unit in the C-can. That includes spare relays, starters, timers, spare airflow switches, and spare stats. So just about anything that can fail on here, there's going to be a spare part in the C-can. And hopefully that gives you a good overview of how to troubleshoot this unit and what to look for when you're trying to find the problem.